Hello class, this is another example from your 171 homework from section 1.2. So what we're being asked to do here is graph both of these in the same rectangular coordinate system, okay, and describe how the graphs are related. So the way you have to do this is you have to plot points in here. So what I'm going to do, I'm going to show you A, how to have your calculator help you, but B, just the theory behind what it is you're doing. So technically what you're doing here is taking the function that you're given, so f of x equals 3x, and you're picking numbers for x to be. So if x is 0, that means f of 0 equals 3 times, remember, when 0 is the input, that means to replace this with 0, and then do the math. So 3 times 0 is 0. And remember, f of something means the same thing as like y. So when x is 0, y is 0. So that's the point 0, 0. So I know that 0, 0 is on this graph. Now, if x were something like 1, so that would mean find f of 1. So that means 3 times 1. Okay, 3 times whatever x is 1. F of 1 equals 3 times 1. So the y-coordinate when x is 1 is 3 times 1, which is 3. So the y-coordinate is 3. So that would be the point 1, 3. So 1, 3 is on the graph also. So 0, 0, 1, 3 are both points on this graph. So what I do is I take this line tool here. Okay, this is a line, mx plus b, 3x, 3x minus 5. These are both lines. If that power on x is 1, meaning it's not there, then you're dealing with a line. And then I just plot those 2 points. Notice up here it's giving me what point I'm on. And I need to plot 0, 0. Alright, and then click and then go 1, 3. Alright, and then notice again up there, that's where those points were. So there's the first line. There's f of x equals 3x. Alright, and then we do the same thing with 3x minus 5. Now, all I'm going to do here, I'll kind of cheat a little bit. Let me change this from an f to a g. And then g of x equals 3x minus 5, and I'll just subtract 5. So when x is equal to 0, so when x is 0, 3 times 0 is 0 minus 5 is negative 5. So instead of 0, 0, now it's 0, negative 5. Alright, and when x is 1, 3 times 1 is 3, 3 minus 5 is negative 2. Alright, so instead of 1, 3, now it's 1, negative 2. So 0, negative 5, 1, negative 2 are on the graph. Alright, so, oops, I add another line tool, 0, negative 5, alright, and then 1, negative 2 are on the graph. So save that. There's both of them. Check my answer, that's good. And then how is the graph of this related to the graph of this? Now, pull it up again. This was our f, this was our g. So the thing that can be confusing is, depending on how you look at this, it can look like it's moved from left to right. Alright, but notice it's 1, there's 2. It's not 5 units to the right. So this one right here, even though it does look like it did shift to the right, that's not correct. It didn't go 5 units to the right. What it did do is go 5 units down. Okay, so that's the answer here. And what we're going to find out more of in 1.6 is how adding, subtracting, after you've multiplied, before you've multiplied, all these different things that you can do to these original functions, how that changes the graph of those functions. So we'll get, right now you're just plotting points and getting used to that, but we're also going to be able to do it more than just those types of transformations. Alright, now with your calculator, remember f of x, g of x are the same thing as y. So these are both y equals and y equals. So I can go to the y equals screen and type in 3x, and then type in 3x minus 5. Graph both of those, and then there's our Same graph that we see here. Okay, the only difference is this is a square, this is rectangular even though it's supposed to be a square, and the edges are at -10 and +10 rather than 15. Alright, but you do see the same parallel lines. To get some points to plot, hit set a graph, hit second graph, that's the table, and then you can plot any of these points. Like for instance, if I in here, if I would have plotted, instead of the points I did plot, 0, 0, and 1, 3 right here, I could have plotted -2, -6. So there's -2, -6, -2, -6 right there, and I could have plotted 3, 9. So there's 1, 2, 3, 9. So I could apply those 2 points. It doesn't matter as long as it's 2 points on the line. Now, you do need to know, to be able to do this problem, you do need to know that those are lines. So if you don't recognize those things, then use your calculator to help you graph them, and then see that they're lines in your calculator, and then know to use the line tool. Okay, it's going to be important that you can use your calculator to help you know what to do, like that kind of preemptively do a problem with your calculator, and then use that, what the calculator gives you, to kind of proceed through.